is common to these two terms? No, x is not a factor that is common to both. Exactly. That I have to agree. That is common to both. Absolutely. And it is pulled out. Perfect. Excellent. What is left from the first term? Excellent. Now I reached plus. What is left from the second term? Perfect. Now what do I write here in brackets? So this is x plus 2y times what? That's it. Very good. Finally, we get to the second page. I hope you filled this in with the formulas. A squared minus b squared is a plus b times a minus b. This is not factorable. This is a minus b times a squared plus ab plus b squared. And this one is a plus b times a squared minus ab plus b squared. Okay, so now we are practicing with these and then continue with trinomials. So I have 4z squared minus 25. Remember the strategy. I have to go through 4 steps before I even get to the special product. The first step is, what type of polynomial is it? What type is it? It's a binomial. Second question I have for myself is this in descending order? Yes, of course. Third question is there a common factor, a greatest common factor that I can pull out from both terms right away? No. The next question is there a negative leading coefficient in the problem? What is the leading coefficient here? 4. So there is no negative leading coefficient. Now I'm asking myself, is there a special product that I can use here? If there is no special product, then I have to write it's not factorable. Is there a special product here? Look at the 4 special products. We just discussed one a minute ago that can be used even to rationalize or divide polynomials, or divide complex numbers. In other words, I'm asking myself, is this a perfect square or a perfect cube? Is this a perfect squared or a perfect cube? And then I will decide. Is 4z squared a perfect square or a perfect cube? If it's not, then I'll have to write prime. Or not prime, but I don't really like that, but not factorable. Is 4z squared a perfect square or a perfect cube? Good. 2z. Very good. So is 25 a perfect square?
I wanted to say 5.
Good. So then it's a difference of squares. So now I can immediately write the factored form. What is the factored form then? 2z
Plus
5.
2z minus 5.
That's it. Next example. X to the 4th minus 81. I go in my head quickly over the same 4 steps. What is it? Good. Is it in descending order? Greatest common factor. Common factor to both. X to the 4th and 81 have nothing in common. Good. Negative leading coefficient? No. Special product? Are they perfect squares? Are these 2 terms perfect squares? Are they perfect cubes? Okay. What about the second one?
Yes.
Good. So then?
X squared. Well, I'm sorry. Did we start that process yet? Is that right?
Yes, we are ready.
So we get x squared plus 9.
Very good. Can I further factor x squared minus 9?
Use 350.
Let's identify it. Is it a perfect square? Is it a sum of perfect squares or sum of perfect cubes? If it's sum of perfect squares, then I have to write what? If it's a sum of perfect squares, I have to write not factorable. But if it's not, if it's a sum of cubes, then I have to factor it. Is x squared plus 9 sum of squares or sum of cubes?
Squares.
Sum of squares. So is x squared plus 9 factorable?
Yes.
The sum of squares is not factorable. It's in your notes. We wrote x squared plus 9 or x squared plus a squared plus b squared is not factorable. So this can stay. What about this one? Is x squared minus 9 factorable? Yes? Good. How do I do it?
The square root of x squared is x, and square root of 9 is 3.
Good.
So x plus 3, x minus 3.
So whenever I'm asked to factor, I have to completely factor till no factor can be further factored. Linear factors, degree 1, cannot be factored unless they have a common factor, like a number. But there is no special product. I can factor a linear term, a linear expression. Good. Let's move on. Y cubed plus 8. What type of what type of polynomial is it?
Trinomial.
Good. Is it in descending order?
Yeah.
Greatest common factor?
And,
A negative leading coefficient?
No.
Special product?
Yeah.
Which one?
sum of perfect cube.
Very good. When you say that, you will have to have ready a binomial and a what?
Trinomial.
Good. So I'm ready when you're ready with the binomial. Let's establish the signs. It is wise to establish the signs first. What will be the sign inside the binomial? What will be the sign in the middle of the trinomial?
Trinomial.
Exactly. And then the last one is always positive. I don't even have to mention it. Perfect. So can anyone give us what I cubed to get y cubed and what I cubed to get 8?
Y and 2.
Exactly. The rest should be easy. The first term is the first term squared. The last term is the last term squared. And the middle one is just their product without multiplying them by 2. So can anyone give us the trinomial?
Y squared minus 2y plus 4.
That's it. Excellent. Next one. Negative 1 over 16 plus x to the 4th. What is it? Is it in descending order?
No.
No. So I have to rearrange it as x to the 4th minus 1 over 16. Greatest common factor? No. Negative leading coefficient? No. Special product? The leading coefficient is the coefficient of the highest degree. What is the degree of this polynomial? 4. So the leading coefficient is 1. And it's not negative. Perfect. So then what do I do? Special product? I have to establish whether it's a difference of squares or difference of cubes. Good. Once you say difference of squares, then I expect 2 binomials. If you say difference of cubes, then I expect a binomial times a trinomial. But it's not a difference of cubes. I completely agree. So what do I write then?
X squared plus 1/8.
1 over 4, because it's 1 over 4 times 1 over 4. Very good. Or the square root, as you said, of 1 over 16, which is perfect. And the other one?
X squared minus 1/4.
Good. Is the first one further factorable?
No.
Perfect, because it's the sum of?
Squared.
Exactly. What about the second one?
Yes.
How do I factor the second one?
I want to say X plus or minus 1x. And then X minus 1.
Perfect. Okay, 2 more here. 1 over 27 minus x cubed. What type of polynomial is it? Good. Is it in descending order? What is its degree? Right, and that should give me an indication about what type of formula to use, if it comes to that. And definitely not the difference of squares, right? Because the degree is 3. Correct. Good. So then I will rearrange it as negative x cubed plus 1 over 27. But now I run into another problem, which is the negative leading coefficient, and I have to factor it out. Once I factor out negative 1, what is left in parentheses? X cubed.
Or X cubed plus 1/27.
If I write plus, then negative 1 times x cubed is correct, but negative 1 times plus will be negative.
Negative.
Very good. Let's check. Negative 1 times x cubed. Negative 1 times negative 1 over 27 is 1 over 27. Good. So now how do I factor this? I'm finally down to special products. So it's the difference of cubes. Once you say that, then you will give me a binomial times a trinomial. Binomial times a trinomial. What should the binomial be? What will be the sign in the binomial?
Minus.
Correct. What will be the sign inside, in the middle of the trinomial? Good. So can anyone identify the binomial? Once we identify the binomial, we're done. The rest is just clear.
X minus 1/3.
Very good. And now the inside the trinomial, yeah, just follow the pattern. 1/3 times 1/3 times 1/3 is 1 over 27.
Gotcha. Gotcha.
So then the first term is,
X squared.
the middle term is,
1/3 X.
very good. And the last term is,
1/3 squared.
yes, which is 1 over 9. Perfect. Very good. Okay, last one here. X squared plus 16. What is it?
Binomial.
Is it in descending order?
Yeah.
Greatest common factor?
Um,
Negative leading coefficient?
um,
Special product?
and sum of squared.
Good. What do I write?
Not factor.
That's it. So we looked at 4 different special products. The difference of squares, which is very easy to handle. We reviewed it on the first day of classes. It's on the agreement. The sum of squares, which is not factorable. The difference of cubes that we talked about it today, binomial times a trinomial, and the sum of cubes that we reviewed today as a binomial times a trinomial. Just 4 special products for binomials. That's it. We don't have anything else. Good. So now let's move on to factoring trinomials. The strategy is the same, but I will write it again. So factoring trinomials. So this one here was factoring binomials. We only looked at how to factor when we are given 2 terms. Now we're going to look at how to factor when we are given 3 terms. Perfect. First step, what is it? Step 2, descending order. Step 3, greatest common factor. Step 4, negative, leading coefficient. These are all the same from the previous binomials. 5, 6, and 7 are different. Okay, 5. There are only 2 special products here. That's why I reviewed them from the first day of classes, because now I need them backwards. So I would like you to tell me what this is. A squared plus 2ab plus b squared, what does it equal to? We've been talking about it going this way since the... Thank you. See? That's the reason why I tortured you with this from day one. I needed it, and I needed it the entire semester, and I couldn't wait till chapter 6. And the other one, can anyone give us the other one?
A squared minus 2ab
Which will equal?
a minus b squared.
So trinomials only have 2 special products. That's it. Binomials have 4 that we can talk about. Trinomials only have 2. Now number 6. In case the special products are not applicable here, in number 6, I will look at something like this, where this is clearly 1. I didn't put anything in there, which means 1. The last option is the most difficult one, in which the leading coefficient is not 1. And this is the entire strategy for trinomials. There's nothing else that we can talk about in a trinomial. So let's go back to the bottom of page 2, and let's work on these. So if you want on page 3 at the top, you can put the formula in. A squared plus 2ab plus b squared is what again?
A plus b squared.
Yes, that's why a plus b squared is 3 terms, as we know. And a squared minus 2ab plus b squared equals what?
A minus b squared.
Very good. Good, but before that, I would like to just factor the greatest common factor here in 2 examples before we go through everything else. So x squared y to the 4th minus 2x y to the 4th plus 4x cubed y to the 6th. I have to ask myself what this is. What does it represent, so I know how to proceed. So what is it? Good. What is the degree of the first monomial? The degree of the second monomial? Careful. Good. And the degree of the last one? 9. So then this has to be rearranged. That's 4x cubed y to the 6th plus x squared y to the 4th minus 2xy to the 4th. So now it's a trinomial. It's in descending order. Greatest common factor. I always hope for a greatest common factor, to tell you the truth. That simplifies the entire polynomial so much that then if it doesn't have a greatest common factor. So does it have a greatest common factor? I see something present in all of them, which is x. At the lowest power, I see power 3, I see power 2, I see power 1. I also see y. I have to choose it to the lowest power. I see 6, 4, and 4. Which power is the lowest? And now how many terms will you write in parentheses, mandatory? Mandatory 3, because I started with 3. Otherwise, I will never recover them, right? So if I only write 2 terms, then this times this will give me this, and this times this will give me one over the other 2, and then I will not have anything for the third one.
And what happens if, say instead of the minus 2xy to the 4th, what if that had been minus 2x squared?
Then I would have combined them. I would have combined like terms first before factoring.
Okay.
I would have done that first because otherwise I make my life more difficult. First I simplify and then I factor. Remember the two key words in all math classes. Factor, simplify, or simplify, factor. These are the two key words. I have to be in the back of our minds all the time. Okay, good. So then, 3 terms. Good. So what do I write? What's left from the first one?
4x squared y squared.
Excellent. Plus, what is left from the middle one? Excellent. Just x. And what is left from the last one?
2.
Minus 2. Can I recover the trinomial I started with? Yes. This times this is this times this is this, and this times this is this. Good. Next problem. Any questions here? So we've seen solving equations as well. Factoring has a lot of applications. One of them is, as you know, rationalizing, going backwards. The second one was dividing complex numbers. The third one, we use factoring to solve equations all the time, quadratic. And the other application will be the entire chapter 7. I will not be able to make not even little progress in chapter 7 before I know factoring, because everything is based on factoring in chapter 7. Okay, so which page am I on? 4, 5, 6. Okay, so the next problem is 2x squared minus 4x plus 6x to the third. What type of polynomial is this? Is it in descending order? The degree is? Yes. So 6x cubed plus 2x squared minus 4x. Greatest common factor? Excellent. How many terms will you have in parentheses? Yes. And they are?
3x squared
Plus, perfect. Plus,
x
yes,
minus
done. There is nothing else we can do in there. So finally, let's move on to page 3 at the top. We are trying to factor y squared plus 121 minus 22y. What type of polynomial is this? Good. Is it in descending order?
no
Okay. So then I have y squared minus 22y plus 121. Greatest common factor that I can pull out from all 3?
no
No. Negative leading coefficient? No. Now I finally got to the question of special product. So, like before with the difference of squares or difference of cubes or sum of cubes, I'm asking myself, is this a perfect square? Y squared. Then I'm asking myself the same way like I did with the last term there, if this is a perfect square. So, is y squared a perfect square? Good. So is 121 a perfect square? 11. What do you expect to get then? What do you expect to get in here? You expect to get y minus, right. Because we know from day 1 that a binomial squared has how many terms? Exactly. Now, I check the first term, right? When I square this, I get y squared. When I square this, I get 121. But I did not check the middle term. What should the middle term be here? Because we've been talking about this for more than 2 months. 2 times the first times the second, or 2 times the second times the first. 2 times 11 is 22, 22y, minus, minus. Are these the same? Is the middle term here, if I were to expand this into 3 terms, will the middle term here be negative 22y? 2 times y times 11, negative 22y. So then I know this is it. It's not sufficient to only look at the first term and the last term without checking the middle term. So let me give you a counter example. So now I'm going to ask you to factor this. Let's say y squared plus y plus 1. You will say this is a perfect square. You will say this is a perfect square. And you expect to get what? Perfect. But what is the middle term here? Exactly. Look what I have here. Is this the same with that? No. So it's not sufficient to only look at the first and the last terms to come up with a factored form. You must, after you're done with the first and the second, if this, for example, is 7, you're not going to think of a perfect square because 7 is not a perfect square. But if the first term and the last term are perfect squares, you will say, maybe y plus 1 squared will do it. But then you still have to take a moment and verify the middle term. Because you know now that the middle term here will be 2y, and you see that the middle term here is not 2y. So the left-hand side cannot equal the right-hand side. So you cannot blindly say, oh, it's y plus 1 squared. You still have to, at the end, check the middle term. Okay, next problem. Negative 3x squared minus 12x minus 12. What type of polynomial is this? It is trinomial. Is it in descending order? Greatest common factor? Correct, and also negative leading coefficient. Very good. So you put both together. You put together the greatest common factor with a negative leading coefficient. That's what we needed. Okay, perfect. So I factor a negative 3. What is left in parentheses? How many terms will you write?
3.
Yes, and they are?
X squared minus 4x.
Careful. We factored out negative 3. Exactly. Let's write it and then we'll check. And then, right, let's check. When you distribute negative 3 to x squared, do you get negative 3x squared? When you distribute negative 3 to positive 4x, do you get negative 12x? And when you distribute negative 3 to 4, do you get negative 12? Perfect. So now look at x squared plus 4x plus 4. Special product. So it's possible as long as the first and the last term are perfect squares. Are they?
Yeah.
So then you will say, it's probably what? I agree. But you have to check something else. It's not enough. What is the middle term here when I expand it? Yes. Is the 4x here? Then I will say yes. And now the rest should become easier. Descending order, trinomial descending order, yes. Negative leading coefficient, greatest common factor, no. Special product, boom. What do you expect? Careful. If the middle term is negative, I cannot write x plus 2. Correct. Now I have to check the middle term. What will be the middle term in x minus 2 squared? When I square that, I get 3 terms, and the middle term would be, is there negative 4x here? So then it's clear that this is the right factored form. And the last one, a squared plus 6a plus 9. Trinomial, descending order, no negative leading coefficient, no greatest common factor, special product, boom. What? As long as the first and the last are perfect squares, I will hope that this is a special product. And which one? Don't look at the middle term, just tell me what you expect.
Expect 8 plus 9.
X plus A plus.
Oh, 3.
Good. Now I check the middle term. So a plus 3 everything squared will have a middle term of,
6A.
yes, because it's 2 times a times 3, which is 6a, so this must be it. Very good. So now we move away from the special products. Let me remind you where we are. Here is where we are. Coming back to the strategy for trinomials. We're not done with this. Not yet, anyway. So we looked at that situations in which a special product was applicable. Now we are here when special products are not applicable, and then when special products are not applicable. But I still have to go through the strategy before I get here. I still have to ask myself all these steps, or go through all these steps before I get here. If this is not available or not applicable, then I go here. If this is not applicable, then I have to write not factorable. There is nothing else beyond 7. If this doesn't work and this doesn't work and the special product don't work, then I have to write not factorable. Ready? So we are back to type this with 1 in front. 1x squared plus bx plus c. So here's our first example. M squared plus 13m plus 42. Trinomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, no. M squared is a perfect square, but 42 is not. So I'm down to the option in which the leading coefficient is 1. So here's how I address this issue. This number is the product with a sign in front, product. This number is the sum. And I'll explain in a minute how we call that one to be the sum and the other one to be the product. I'll show you in a second. So basically, I'm looking for two numbers whose product is 42 and the same two numbers whose sum is 13. So if you look at what I wrote a square and a triangle. So I'm going to put two numbers in there whose product is 42 and whose sum is 13. So now, because the product is positive, both numbers have to have the same sign. They have to be either both positive or both negative. But because the sum is positive, I know for sure they must be positive. Because, see, the sum is positive. If the sum were negative, then I would have said, oh, the numbers have to have the same sign. In that case, they have to be both negative, so because their sum is negative. But the sum is positive. Can you come up with two numbers whose product is 42, and at the same time, their sum is 13? And the answer is?
7.
Good. In any order. 7 and 6. 7 and 6. Both conditions have to be fulfilled. Are they? So therefore, the factored form uses these numbers. M plus 6, M plus 7, or the other way around. And let me show you why we call this number the sum and this number the product. So you know where that comes from. If I want to multiply M plus 6 by M plus 7, this is what I write. M times M, M squared, plus M times 7, 7M, plus 6 times M, 6M, and 6 times 7 is 42. That's why this number 13 is called the sum, and this number 42 is called the product. So because in this trinomial, this is the product and this is the sum. Look how I get 13 to be the sum of the two numbers I'm looking for, 6 and 7, and how I get the product to be 6 times 7. So that's why this is always the case. This is always the product, and this number is always the sum. The sum of the numbers I need is always the coefficient of the middle term, and the product of the numbers I need is always the last term. But this is true only if the leading coefficient is 1. Very careful. This is true only because the leading coefficient is 1. Okay, the next one. X squared minus 20 minus x. It's a trinomial. It's in descending order. no, and it's not in descending order, so I have to rewrite x squared minus x minus 20. Greatest common factor, none. Negative leading coefficient, none. Notice that I am still going through step by step so I don't miss anything. Because if there is a greatest common factor and I don't factor it out, I make my life 10 times more difficult in factoring this. So no greatest common factor, no negative leading coefficient, special product, I wish. No, no special product. The last term is negative 20. Cannot be a perfect square. Negative 20 is not a perfect square. So then my chance is now, because the leading coefficient is 1, so I'm looking for two numbers whose product will be excellent. You always have to take the number with a sign in front. Very good. And whose sum must be perfect. Since the product is negative, it is clear that one has to be positive and one has to be negative. Since the sum is negative, then the negative number is overtaking the positive number. It has to be bigger in absolute value because their answer is negative. So in other words, I owe you more. So the negative has to be higher. Okay, so I need two numbers whose product is negative 20 and whose sum is negative 1.
Negative 5 and 4. Or positive 4.
Absolutely. The negative 1 has to be bigger in absolute value. Good. So then you tell me how to factor this, and it's done.
X minus 5 times x plus 4.
And that's it. See, this is what students miss in sitting and looking at the computer.
I was about to say, because I remember this from 012 or
011? Yep.
And yeah, it wasn't just in depth. Kind of had to pick it up.
Because in a developmental math, I'm not saying people can do it. I'm saying they need help in doing this. It doesn't click for everyone right away. I may have mentioned this to you. When I was little, I would tell my grandma, can I go out outside and play? I think I mentioned that to you. Maybe not. I did?
I think so.
Yeah. And she said, sure, but you have this to do first. So, but she was there overlooking everything. So, good. So this is my M and this is my N. So normally we arrange polynomials in the alphabetical order, although X, Y, Z, W is what we use for the last letters, although it's not exactly in alphabetical order, but here we normally use M, N. If I have M and N, I use M first, N second. If I have A, B, I use A first and B second. Unless I'm specifically told the variable is really N, and we don't care about M for whatever reason. But here there is no specification. So I will rearrange it based on M. So I have M squared and then the term with M and then the term with no M. So M squared is first, M is in the middle, and no M in the last. Okay, so now.
So we do it that way even though the last one has a power to it, so it's not.
But this one has a power to it also.
Yeah, but the second one doesn't, so that doesn't matter. It's just we
The
always
degree
put
is 1 here. M has power 1, N has power 1. Degree 2, degree 2, degree 2.
Okay.
Good. So descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, no. Negative 150 n squared is not a perfect square. So then I'm looking to find two numbers whose product is and whose sum is. The sum is, yes. The product must be perfect. Since the product is negative, obviously one has to be positive and one has to be negative. So, since the sum is positive, then the positive number is bigger.
Positive 15, negative 10.
Exactly. So, 15 minus 10. So then I know how to factor. What do I write? N plus 15n. Yes. And m
minus 10
n. Exactly. Excellent. Perfect. Good. One more here, and then we'll go to the last possibility for trinomials. So we have x squared plus 13x plus 36. It's a trinomial. It's in descending order. Greatest common factor, no. Negative leading coefficient, no. Special product. Yes, right? Perfect. So what do you expect? Excellent. Now let's check the middle term. What will be the middle term here? But that's the right thing to do. That is the right thing to do, to check special product first. Okay, so it doesn't work. So I have one more chance. The product to be
36.
and the sum to be good. So since the product and the sum are positive, then the numbers must be positive because they have to have the same sign since the product is positive. Good. So I need to find two numbers whose product is 36 and whose sum is 13. That's it. So then x squared plus 13x plus 36. And I found the product, the factor form. What is it? That's it. But this is the right thing to do. Do not skip the special product. You'll make your life so much more difficult here if you do, in case it's a special product. Okay, finally the last one. Let me work on the first example together with you, and then we'll look at the other ones. So now we are on at the bottom of page 3 on the handout, right here, where the leading coefficient is no longer 1. This is the most difficult case. Everything else from now on will be easy. So polynomials are easy, and then we are going to apply them in applications. Okay? So 6y squared minus y minus 1. Ready? Okay. I go through the entire strategy. It's trinomial. It's in descending order. No greatest common factor. No. 6y squared minus y minus 1 do not have a common factor. All three, they do not. Negative leading coefficient. No. Special product. Absolutely not. 6y squared is not a perfect square. Negative 1 is not a perfect square. Then I'm thinking of maybe the leading coefficient is 1. Nope. That doesn't work either. So I'm down to the last possibility. So I'm looking to determine two numbers whose product is and whose sum is. The sum never changes. What is the sum? Perfect. But now the product is different. The product has to incorporate the leading coefficient. So the product incorporates the leading coefficient. How much is that? -6. So I have to multiply now. In order to find the product, I have to multiply -1 by 6. Whatever I have as the leading coefficient has to multiply the last coefficient. In this case, I had 6. If I had 5, I would have multiplied by -1. I would have gotten -5. Now I'm back to the same question. I'm asking myself, okay, can I find two numbers whose product is -6 and whose sum is -1? Since the product is negative, one has to be positive, the other one has to be negative. And I note that since the sum is -1, the negative number has to be bigger. Say it again.
-3 and 2.
Very good. Now this is guaranteed, right? 2 minus 3 is -1. 2 times -3 is -6. Both conditions have to be fulfilled. Here's what happens next. This is not trivial. Careful. I will be using these two numbers like before, but not in the same way. I will rewrite the polynomial and replacing this using these numbers. So instead of negative y, I will write positive 2y minus 3y with the numbers that you just gave me, and then I copy the last term. So what I really did, I found the numbers this time, but I can't factor using them. I can just replace the middle term by two other terms that will help me factor. So here, these two numbers, because the leading coefficient was 1, these two numbers allowed me to factor right away. It was done. But here, because the leading coefficient is not 1, I have no choice. But there is another method. If you prefer the other method, you can look at in the book. But this is the method I need because it's called factoring by grouping, and I need it for factoring polynomials. So I have to teach this no matter what. Even if I show you the other method, I still have to teach this part because of polynomials. You'll see in a minute. So what I'm doing now is I'm rearranging or rewriting this term as these two terms. I'm not changing the problem. I'm just replacing this term by these two because 2y minus 3y is still negative y. But now I will use factoring by grouping in the following way. I covered the last two terms, and I'm going to ask you, if you had only these two as a binomial, what would you factor out? Very good. What is left in parentheses? Careful.
6 plus y.
Careful.
I'm sorry. Would it be 6 plus
2y multiplied by something has to give us 6y squared.
3y?
Very good. Plus 2y multiplied by something has to give us 2y.
You factored out y, right?
1. Perfect. What should I have in parentheses coming from the other two before I even look? Because if I don't have the same thing, I can continue. And then I will talk about this part. But tell me, what should I have in here so I can continue? It has to be the same. I will not be able to continue if it's not the same. That's why I write it before I even look. Because I may write 3y minus 1 for whatever reason. And I want to avoid that. That's why I covered it. So now I uncover it. I want two things from you. I want a sign and I want a factor. So I want a sign here and a factor here. Tell me, what should I put right in front of this? What times 3y is this? What times 1 is this? Exactly. Exactly. Now I see two terms. What comes out? What is the common factor of these two terms? That I will have to put in front, pull in front. What is it? Three y is not a common factor, but indeed, that is a common factor. What is left from the first term? I pull this out. What is left? I pull this out. That's it. Let's check now. We want to check our work. Let's do it together. 3y times 2y. Is that 6y squared?
Yes.
Negative 3y plus 2y. Is that negative 1?
Yes.
And positive 1 times negative 1, is that negative 1?
Yes.
I want to skip part B and do C first, and then coming back to B. I want to do one more example before we do B. So 4x squared minus 4x minus 15. So teach me how to do this.